All right, so here's another example on how to calculate the time elapse of an ultrasonic sensor at a particular distance. So if we see over here, this is a picture of what an ultrasonic sensor looks like. So this is the sensor. This is the emitting portion of it, and this is the light going to the right. And this is our object that is hitting. And then that sound wave is going to bounce back and go into the receiving part of the sensor. And then from there, it's going to calculate some type of distance. That's what the sensor does pretty much. All right, so we have a problem here. It says calculate the time it takes for a ultrasonic sensor to detect an object at 50 meters. So this distance here in our example, this distance here from the sensor to the object is 50 meters. Okay, and so we want to figure out how long it takes for this sound waves to go from here, bounce back all the way to here at 50 meters. So 50 meters, so that is if you take your left hand and you extend all the way to the left and extend all the way to the right, that's 1 meter. So that's 50 of those. So it's a pretty large distance. So let's go ahead and solve for it, the time. So we're going to first start off with our knowns. We're going to do a conversion. We're going to get some new knowns based off of that conversion. Some new. We're going to use an equation. We're going to plug slash chug, so P slash C, plug and chug, and we're going to get an answer. All right, so let's first start off with our knowns. What do we know? All right, so we know that we have some type of speed that's given to us. The speed is 340 meters per second. And we have a distance. We said our distance was 50 meters. And we know we have a time. And that is what we don't know. All right. So next with our knowns, our conversions. So when we're doing conversions, we're doing this because we want to make sure that the numbers that are given are going to match up. Because if the units do not match up, your answer will be off. This answer will be all the way off. So we have to make sure all the numbers match up based off the problem in a certain condition. All right. So there's one condition that I didn't say. So when you're dealing with sound waves, because sound waves go 340 meters per second, we have to account for how fast a sound wave can come back. And so usually sound waves are generally on the scale of a microscale. All right. And 1 microsecond, all right, because we're dealing with time, the time it takes for the wave to go from here to here, the time it takes, 1 microsecond is going to be 0.0000001 second. All right. And so to put this in perspective for you, this is 1, 2, 3, 4, 5, 6 times smaller than 1 second. So 1 second is very short. So imagine how short this is. It's a sound wave. It's going 340 meters per second, right? So we have to do a conversion. So let's go ahead. We're going to convert this seconds to microseconds so our number can it can look right. All right. So we're going to first, it's going to be a one-step conversion because we have one conversion factor. So we're going to do 340 meters over second. And we said this is a one-step conversion, so you're going to have one T-chart. All right, so we want to get rid of this second. So I have my number with the seconds is going to be 1, 2, 3, 4, 5, 6. So that is 0.000001 second. That's going to go at the top. And you know you did it correctly because the units will cross out. seconds. And then how many microseconds does that equal? That equals 1 microsecond. All right, and so if we get our calculator, we're going to do 304 times 0.000001. And what does that give us? That gives us 0.00034. So our new speed, let's say our new known, it's going to be 0.0034 microseconds. Oh, excuse me, not microseconds. It's going to be meters per microsecond, right? Because this is meters and we only changed the second. All right, so that is our new speed. Let me rewrite that. Point 0.00034 meters per microsecond. All right, our distance is still 50 meters, and our time, that is what we're trying to find. All right, so now let's solve for the time. What is the equation for time? Time is t equals x over s, distance over speed. All right, plug and chug. Our distance is 50 meters divided by our new speed, 0.00034 meters per microsecond. So the answer is going to be t equals 50 divided by 0.00034. So that is going to be 147,058. 147,058 microseconds. All right, and so to put this in perspective for you, a microsecond is 6 steps going down. So if you want to put it in its base form, it's going to be 0.23456. So the time in terms of seconds is going to be 0.47 seconds. You don't really need that anymore. So it's about less than a quarter of a second. So for a sound wave, that's pretty long. And it's long because the distance is pretty long. Like I said, 50 meters is pretty long. So this makes sense. Our time is going to be very long because we have a very long distance. If our distance was short, we'll have a very short distance. All right.